Time seems so simple. It flows like a river, always in one direction. We wake up, live, grow older, never younger. But why is this the case? Why does time only move forward and not backward? This question, deceptively basic, cuts to the heart of physics, cosmology, and the nature of reality itself. It touches everything from thermodynamics to consciousness. And while we live our lives assuming that time flows, science has shown that things are far more complex. At the core of this mystery lies the concept of the arrow of time, the idea that time has a preferred direction. In most of our everyday experiences, this direction is obvious. Eggs break but don't unbreak. Ice melts but doesn't refreeze spontaneously. People age but don't grow younger. This direction is closely tied to the second law of thermodynamics, which states that in any closed system, entropy, a measure of disorder, tends to increase over time. In other words, the universe naturally moves from order to chaos, from usable energy to unusable heat. This law gives time its arrow. It's not that the fundamental laws of physics require time to move forward. In fact, many equations, including Newtonian mechanics, Maxwell's equations, and even quantum mechanics, work equally well in reverse. If you recorded a billiards game and played it backward, the physics would still be valid. So why don't we see that happen in real life? Because while the laws of motion are reversible, entropy is not. As systems evolve, they become more disordered. And once that disorder increases, it's almost impossible to reverse. Think of mixing cream into coffee. Technically reversible, but practically impossible. This suggests that the arrow of time is not a fundamental law, but an emergent property of thermodynamics. Time appears to move forward because the universe began in a highly ordered state, the low entropy beginning we call the Big Bang. But why was the early universe so ordered? This remains one of the deepest unsolved questions in physics. One possibility is that the initial conditions of the cosmos were just right, a unique configuration from which entropy could increase. Another view is that the arrow of time is tied to the expansion of space itself. As the universe expands, entropy grows, setting a direction for time to follow. There are even theories suggesting that the arrow of time may reverse in a contracting universe, or that multiple arrows of time may exist in different regions of a larger multiverse. In these speculative models, time might move backward elsewhere, or even loop back on itself. Quantum mechanics also raises profound questions. In the quantum world, particles exist in a state of superposition, only settling into a definite state when observed. Some interpretations, like the Copenhagen interpretation, suggest that the act of measurement introduces a kind of collapse, a transition from probability to reality. But again, the math doesn't require a direction. In fact, the Schrödinger equation, the central equation of quantum mechanics, is perfectly time-symmetric. So where does the asymmetry, the one-way flow, come from? Some researchers believe the key lies in the interaction between quantum systems and their environments, a process called decoherence. As quantum systems interact with the macroscopic world, they lose coherence and become classical, and in doing so, the system's entropy increases. Thus, decoherence may link the quantum and thermodynamic arrows of time. Consciousness also plays a role. Humans experience time subjectively, as memory, anticipation, and the sense of now. We remember the past, not the future. We can't unknow something we've learned. These asymmetries are built into our cognition and likely tied to entropy as well. Memory itself may depend on the irreversible flow of information, encoded by brain processes that rely on thermodynamic changes. We live forward in time because our biology, like the universe, runs on increasing entropy. But some thinkers go further. They ask, what if time isn't flowing at all? This leads to the idea of the block universe, a concept from relativity, in which all points in time exist simultaneously. In this view, the past, present, and future are equally real. We don't move through time. We simply experience different slices of a static four-dimensional structure. From this perspective, the arrow of time may be a psychological illusion, a function of consciousness moving through the block. We perceive time because we're built to do so, not because time flows. Still, whether time is flowing or we're moving through it, one thing is certain: the universe has a preferred direction. And that direction shapes everything we do, from how we build machines to how we define life itself. The arrow of time explains why we age, why we remember, why cause comes before effect. It underpins our laws, our stories, and our sense of identity. And yet, it might be one of the most fragile things in nature, arising from an initial state we don't fully understand. If the arrow of time can be reversed, altered, or even stopped, what would that mean for us? Could we rewind life like a tape, unmake decisions, undo mistakes, or would we simply vanish, our identities forever tied to the forward motion of thermodynamic time? These questions may never be fully answered, but in asking them, we deepen our understanding of existence itself. Because time is not just a number on a clock, it's the canvas of reality, the stage on which every moment, memory, and miracle unfolds, and the arrow that pierces through it all is still flying.